Hello, Fáilte Seach into this third video of this series looking at the front wing and specifically the airfoil of the front wing of a STEM racing car. In the first two videos we looked at the design considerations, the choices to be made in selecting an airfoil and as well as that getting the coordinates, deciding on thicknesses and chord lengths that will both satisfy the STEM racing regulations and also lend itself to what we're trying to achieve aerodynamically with the airfoil. So in this third video, we're going to pick up from where we left off, which was um, the saving of the coordinates for a NACA 0009 airfoil to a WordPad document, to a text document. What I'm going to go ahead and do now is I'm going to launch ANSYS Workbench. I'm working with the 2025 R2 version here, and this is a full operable version. It's not the student version, and ANSYS have very generously made these licenses available for teams that have an academic partnership or institutes that have an academic partnership, or indeed teams that are participating in both STEM racing and in Formula Student. And as it so happens, within the Southern Regional College this year, we are participating in both. So I do have a license for this as an academic supervisor, as do the team members for our STEM racing team. So if you are still working with ANSYS Student and you are getting it tight for whatever reason to run your simulations due to the limitations of that license type, my suggestion would be to get in touch with your local ANSYS reseller or ANSYS themselves, and indeed do a Google on the academic partnerships and the team. In fact, if you just bear with me, just when we're here, I'm going to go off topic a wee bit. If you did go to STEM racing and to your jurisdiction's local, let me see, local STEM racing. There's global STEM Kimmeru. Oh my god, just cannot see why I have STEM racing. Let me try stemracing.co.uk. Unbelievable. You know what I mean? Let's try it in Chrome. There we go. Again, we can see partners. There's ANSYS listed as a partner with STEM Racing. Take this on down. So there we go. ANSYS equips STEM racing teams with free access to world-class simulation software and learning tools. So absolutely phenomenal. Actually get in touch with them, access for students, or request a partnership. All right, request the ANSYS partnership here. They are hugely obliging, and my suggestion would be to go to them. It's fantastic software. I've been using it for a long time, and I would never look past it. So there is the workbench now launched. Again, I'm going to head over to the side. Again, I'm going to slightly minimize this because I have a toolbar. I don't know if it's visible on the screens that you see. On the left hand side, that is not letting me see what's on the component systems. Now generally whenever you open up the ANSYS workbench, the analysis systems palette here will probably be open, and you'll see most places they'll say pull in fluid flow fluent or CFX or whatever you're running with. I prefer to use the component systems and build it up modularly. Again, it's just a preference, and it's just maybe indicative of the background that I have with the software and habits. But what I'm generally going to run with here is the mesh tool. I'm going to pull a mesh tool in. And you can see straight away that the geometry is included within this. All right, so you can pull in geometry there, but you're going to have to pull in a mesh after it. So when you pull in mesh, it tends to bring in the two. When I select geometry, I'm going to come over here to the properties. So again, if the properties palette is not visible, if you do right click onto the the project schematic page there, and you click on the properties, you can see it there. Clicking on the properties, the analysis type, I'm going to change that to 2D because I want the software to know that I'm only going to be looking at a 2D analysis here. I'm going to come into units, and what I'm going to do is change from kilograms meters down to kilograms millimeters, again just for the scaling of the project. And when I pull in these coordinates, I want the software to interpret them in millimeter dimensions, millimeter points, or points scaled to millimeters as opposed to meters. Geometry. Right, so if you right click it here, you can have a range, discovery, space claim, design modeler. I believe space claim is being phased out. I would have traditionally always worked in space claim for 3D analysis and design modeler for 2D analysis. In later years, I've moved everything on to 2D analysis, even in space claim. And now they're going phasing it out, I believe. So I had purposely avoided discovery for an awful long time. Discovery is brilliant, for a lot of reasons, especially if you don't want to get into the full, maybe say fluid analysis or CFD analysis that Fluent or CFX would bring, and you want to just to get a better idea of the flow field. Discovery will facilitate that. But with space claim phasing out, I'm moving on to discovery, and I will concede to say that it is reluctantly that I'm doing it, but there you have it. And by no means adept at discovery just yet, so bear with me on this here, please. I don't think that I've seen outside of the ANSYS learning library YouTube videos in which the CFD on a 2D airfoil has been carried out with the geometry being set up in discovery. For the most part, they've been set up. No Anthony T and Killian Thomas, which are absolutely phenomenal videos, absolutely well put together and very clear, very coherent. They both set up their geometries in design model, and they did it, I must say, very well. But I'm going to try to do it in discovery. So you can see when you first open it up, I'm in sketch mode here. But what I'm going to do before I even start sketching is I'm going to come on into here and come into settings. And what I've seen when I come to units and display precisions, that's all fine. I can still use my lengths and meters and all. But what I want to do is my grid spacing. Now my grid spacing here, I have it down to 1 millimeter, 0.001 meters. What I'm going to do is I'm going to make that a wee bit finer. Right? I'm going to put that down to half that size and put it down to 0.5 millimeters. Okay, and that's, let's see, that didn't want to update that. 0.0005. Do I need to put that up to 20? Does that make a difference? No. Let me just check one thing. If I change that to millimeters, will that let me put it to 0.5? Yeah, maybe that's it. Maybe there was a limitation there. As I said, I haven't used Discovery much before, so there you go. I've changed that to millimeters. It was probably a limitation on the amount of digits I could put in, post-decimal and decimal places I could put in. But there you are. That's back into that. Now, I'm not very clear what plane I'm in, but this could be like Design Modeler, and what I can do down here is I can select a new plane. So what I'm going to do is I'm going to select the XY plane, and then I can hit view to come straight in and look directly on that. Why? Because on a 2D flow, the default direction of flow in the 2D flow is in the X direction, normal, to the YZ plane. So I'm going to come in this way, and what I'm going to do is I'm going to set the profile of the airfoil in here so that the flow is approaching it from the left hand side, flowing over it as it exits out the right hand side. So from the last video, we set up this coordinate file here, which was pasted in from an Excel record of these coordinates. It's going to close us down from the last one. I'm working on this plane. I'm going to insert geometry, and there it is there. That's the one I had saved to, and bring that straight in, and there is my NACA airfoil on that. All right, so now if I come back into 3D mode here, what I can do is I'm going to fill this up to create a surface from it. I'm going to select that and hit tick, and now I have a surface. All right. So that's nice. There is my airfoil. All right, so what I want to do now is I want to draw this is an external flow field over what's going to be a solid structure here. So what I'm going to do is I want to build a flow field around this airfoil. So what I'm going to do is come back onto the sketch again. I'm going to select this front face. It's not just clear to me that I am selecting the front face here. So if I was to put it this road, and I can just make sure I select that face, which I have now, I believe. I've come into here. There's my origin there. What I'm going to do is I'm going to set up a construction line. I'm going to start it at the origin and I'm going to pull it back. This is 25 mil long airfoil. So I think I'm going to pull it back in about 1 millimeter. And I'm going to take a construction line from that 1 millimeter point, and what I'm going to do is I'm going to run it up 15 chord lengths. Now 15 chord lengths to come up the way, so 15 by 25 is 375. I'm going to run up that road there, and then I'm going to do the same down the other way. Well, I don't even really have to. I'll leave it just going up one way. I'm going to come up to here, and what I'm going to do is I'm going to draw or sketch around a swept arc. I'm prompted here to select my center point, which was in there. I'm going to bring this all the way up to the 375 mark there, and you see there it's giving me a diameter of 750. Absolutely, I'm going to swing that all the way around to there. Now I'm just going to make sure there's 3.1 radians or pi radians, that I don't go past pi radian mark of the 180 degrees. I don't snap back onto the origin, which is probably back there somewhere, that I do come all the way around to a solid 180 degrees, which is there. Now what I'm going to do is I'm going to take a line from my top point, and what I'm going to do is I'm going to come back 20 chord lengths to the back. So 15 above, 15 out in front, 20 chord lengths to the back. So my chord length in this case again is 25 millimeters. If I come 20 chord lengths back, that is 20 25s, which will bring me out to 500 millimeters. And then I'm going to come on down to here, 750 down, which is the diameter that I had my swept arc, and then I'm going to bring it here and I'm going to close it up 500 mil. All right. So there it is there. What I might actually do is I'm going to put in another construction line here, and I'm going to bring this on down, and this will help me split up my flow domain, hopefully. Bring that down to there. All right, and that's it. So there's a flow domain. So again, this is what's called, by the way, a D-type domain. You could have a rectangular domain, a square domain, you know, H domain, I believe they called it officially. And that's just square. Why didn't I use it? Well, there's really no need. If you make a H domain, it'll work fine, and I can just bring my air straight in. But what I'm doing is I'm including a lot of area here in which I'll have to mesh or use up cells or elements in areas there of very little interest or very little change with respect to what this airfoil does on the flow field. So by bringing this round into a radial curve like this, what I'm doing is I'm excluding these areas down here, which are going to have very little impact on the aerodynamics of anything immediately before, above, below, or indeed aft of the airfoil itself. So it's space saving. And you can also have circular domains here as well, you know, as opposed to coming out square. But why not use a circular? Well, up here, you know, there could still be elements of wake. And if I use a circular, especially on the aft side or downstream of the airfoil, there's areas of interest up here and down here that I might want to maintain. Okay, but up here, potentially not. Why so high as well? A lot of people might ask that. You know, how come you have to go 15 chord lengths up? Well, the fact of the matter is, there will be effects far off of the airfoil, and again, that there is also part of this kind of pinch idea that often comes in when people try to explain lift of airfoils. Happens is generally immediately over, like what keeps the air pinned onto the to follow the shape of the curve, and as the air comes over, why is it encouraged round here? Some people tell you that, it's because of the no slip condition on the airfoil, but that's not strictly true. The no slip condition, yeah, indeed it does keep air on the airfoil here onto the surface, but that isn't what contributes to the kind of accelerating the air, the change in the direction of the air onto it. But what does happen here is that as the air is kicked up a wee bit, there's a pressure gradient builds up across these streamlines, which are immediately affected. Now the air up here doesn't change pressure much; it's still free stream pressure as is down here. But within this kind of area, not within the boundary layer now, just above it, there will be a pressure gradient across these immediate streamlines, and it is that pressure gradient that pulls that down. But that pressure gradient there itself exists by virtue of the fact of what's above it as well. And indeed, the pressure here, even though there is a higher pressure at the top really than there is to the bottom, given that we're going to have a very low pressure acting on the surface here, this pressure gradient doesn't affect the surface itself. It only acts on the streamlines, both above and below. So there will be knock-on effect, and that's probably explained very bad. But if you do want to further explain it, I just realised I'm 15 minutes in already. Please let me know, and I'll talk more specifically about that. Again, a lot of them things, your understanding of that and your demonstration to the judges in the stem racing competition that you have command, or at least a fairly healthy awareness of these aerodynamic effects, will help your cause. It'll instill confidence in the judges that you know what you're talking about. And indeed, unless you know what you're talking about, don't put something forward. All right, put everything you can forward, but make sure you fully understand it first. And if there's any difficulty with that, make sure don't be stuck. Let me know, or somebody else. But anyhow, that's our D shape domain. All right, so when I come back out of here, I'm going to move back into out of my sketch mode into my 3D mode, and what I have is it's automatically generated me a surface, given that I have an enclosed boundary. But what I want to do now is I want to project this shape onto that. I actually have that shape and I have that shape. The two exist separately. I don't really want that. I want them to be the same thing. One surface, because my analysis is on a surface, and that isn't contributing. I just want a hole in my domain, so it can treat that as a void effectively. So what I'm going to do in here is I'm going to go to project. So this always gets me, it looks like project, but it's project, obviously with respect to sketching. So if I click a project, and what it says to me here is, what do you want to project in the first thing? So on the top one here, select the curves to be projected. That's the curve there. Now I'm going to scoot on down to this third one down, select the faces that you want to project it onto, click onto that, and it's this big yellow face. And that's it. And then when I hover over the check, if I see that going pink, I believe things are looking good. Click that, and there you are. So now I have that, and I have that, right? So if I take that and I delete that out, what I've done is I've just left a big hole in the domain there, which is looking pretty good. Right, so that's where my flow is. This is the only place that there is, it's not material, but a area or a section that I can carry an analysis on. This is now gone. That grey area in there is equivalent to this grey area out here. It's just nothing there, but the shape's there. All right, what I want to do now is I want to split this domain up. So what I am going to do, there's a couple of different things you can do in meshing. I should actually do a copy of this and show you the difference between a structured and an unstructured mesh. But what I can effectively do is not do anything. I can just bring this into meshing. I can discretize or split this whole yellow, what looks like yellow flow domain, into a series of cells, just a big grid, and then provide an inflation layer, which is a very refined and thin section of ever increasing cell heights from an initial cell height, which is going to be based on what's called the Y plus value. We'll deal with that in a later video. Out to kind of a free stream cell size. You can do that, surely, but if you have the computational power available, going with a structured mesh is a much better option. And again, Anthony T and Killian Thomas and others have done this structured mesh, and there's absolutely phenomenal results about it. So there's no point reinventing the wheel. I had played around with doing my own wee things, creating another surface immediately around the airfoil, putting a very fine mesh in it, and then maybe doing some sort of a base meshing onto the outside just to put my own stamp on it. But it's very hard to beat something that works so well, and theirs does work so well. So if I click onto this onto this flow domain, I want to split it up. I'm going to click split. I'm going to go here to the perpendicular cotton. Okay, what I'm going to do now is I'm going to come all the way on down to here, right, to where that construction line ended. Click it in there, and I have effectively split that from that front and back across that section of the airfoil where I went back to 1 mil. Now, what I also want to do is I want to split this one. So click split again, and I'm going to come to, best I can, the aftmost point of the trailing edge, and I'm going to split it there. So now what I have is a very defined section above the airfoil, slightly downstream from the leading edge, below the airfoil, slightly downstream from the leading edge, and then aft or at the trailing edge I have an above and below wake region immediately, and then more to the free stream. Now what I want to do as well is I want to split the front of this. So again, I'm going to come to the split command here, right? And what I can do is I can take it to the right in here, right, to the origin splitter there, and I have that. I have this kind of nose section in that. So these are all points here in the free stream, and where we're converging into the foremost point on the leading edge. This here is kind of a dead region at the minute. I'm going to sort that out in a second, and then above and below, and then aft. Right, what I want to do is I'm going to take the two of these here, and them two sections, I want to join them. So I'm going to come on into repair, and I'm going to merge them faces, hit tick, and do the same on the underside, merge faces, hit tick. There you are. So now I have 6 faces. Bang, bang, bang. 4, 5, and 6 faces. Nice job. All right, back onto the design. What I'm going to do now is I want to escape out of everything now. Just keep pressing the escape key. I want to create name selections. So I want to specify where my inlets, my outlets, my walls are, and any other boundaries for the specification of this flow field. So clicking this front upper curve, this front lower curve, this short wee curve or line there, curve, and the top one as well. 1, 2, 3, all the way around 4, 5, and 6. Them 6 lines, those are my inlets. Right, that's my inlet. So inlet is kind of a deceptive description of the description of that. Inlet, automatically you think normal to the surface, that air is going to be coming in straight arrows all the way around that. Yeah, that's the way Fluid sets it up as default, but we can change the components. We can change the velocity into a 2D analysis into its X and Y components, and we could say there is no Y component. It's going all parallel here with the x-axis. So up here, all we're saying is that air along this streamline is just scooting the whole way through there. Okay, it's just coming in on straight lines as opposed to coming in. So yeah, absolutely, that can be an inlet. Why not make it a wall? Well, you can. Absolutely, you can make that a wall if you want, but the only effect is that if there is any sort of physics happening up here, or any effect of the airfoil way up here, even though it's 15 chord lengths up, what you will do is you'll start to get wall effects up there as well, which could adversely affect your flow field in here, which can have a knock-on effect here, and eventually they will resolve to some sort of a steady state. But it might not be accurate to what's happening. So if you can imagine in a 2D world, if that is the front of your wing, your front wing, apologies, and this is above the front wing, and that is on a table that is 1.2 meters off the ground, and your ceiling is 3 meters high, that's the closest boundary above your car is going to be the ceiling. So it's a vast distance up. So if we're only going up that height, which might be at your head height really, if you're looking down on your car, there is no boundary there. It's just air. So that's the way we're going to keep that. So I have the 6 of them selected. I'm going to come on down into here, name selections, click onto name selections. I'm going to click the wee label with the plus, selection 1. And what I'm going to do is I'm going to call this an inlet. I usually use the caps on these, just personal preference, inlet. I'm going to click the 2 back lines here, and hopefully you can predict what I'm going to call that. If that's the inlet, by the time I have calculated everything that's happened in my flow region, it's time to send it out. So yes, indeed, that is the outlet. Right. I can select these. I can call them a flow field. Normally, I always would have, especially in the 3D application, give that a name selection and call that flow field if I want. Or you can, in a 3D, you might split it up and have a near field and a far field. But it's a wee bit of an overkill maybe for this. But what I will indeed do is, before I do anything else, is I'm gonna drop down my design up here. See this curves. I actually let me just take this name selections away. Curves. I'm going to delete that curves, because now when I deleted the curves, I can get access back onto this boundary of these split regions. So I'm going to select that boundary, come back then into my name selections, add a new name selection to that, and then call that wall. No, it's not a wall, it's a surface, it's an airfoil. But whenever we bring this into Fluent, there'll be other words that are very close to flow field and world that are by default put it in. When you have a wall, it is a wall. Okay, that is the wall there. I hope it did select that. I think I did. Alright, that's it. I can take out that sketching plane as well if I want. It's not need. Also, I really want the surface. And indeed, what I can do is I can F2 that and call that flow field if I like. The surface itself, flow field. Alright, there you are. Oh, I don't have a selection set there, so let me just add in them now, right? There we are, that's better now. When I took away the sketch, it actually let me select them boundaries. Now, I'll put that in as a wall. There you are. So that's something to be careful of. If it didn't come up, it means you didn't select it. It's only when I deleted away the sketch, or what you can do, I think you can right click them and you can suppress them or hide. There you are. Maybe you wanted to hide it if you didn't want the kind of finality of deleting it, but nevertheless, I deleted it. And there you have it. I was able to access what are effectively the boundaries now. Right, so it is the boundary that I was looking at, and that's it. Right, so if I go to Z, that'll give me a zoom extent, and there's my flow field. The airfoil is so small you can't even really see it until you zoom in. But that's it. We're not really interested in what's happening on the airfoil. We're interested in what's happening around the airfoil. Okay, so we're coming up on the half an hour mark there again. So the 20-25 minute video things isn't really happening. I'll try to keep them 30 minutes from here on in, and I'll close this video up now with this geometry setup, and in the next video what we'll do is we'll look at meshing this, and then following on to that we'll apply the physics in the solver for the computational fluid dynamic analysis on this airfoil. Yep. So thanks very much for staying tuned onto the video, and as always, if you have any questions or any comments or anything like that, yeah, be sure to give me a shout. Thank you.